Okay, so we're going to pick up here. We just talked about how to solve polynomial inequalities. Now I want to go over how you handle it if it is a rational inequality. All right, so remember, a rational inequality means that you're dealing with a fraction, and inequality still means that there's going to be like a less than, greater than, one of those kind of symbols in your equation. And so these we're going to handle a little bit differently than like the polynomial ones, because we're not going to be able to just factor it or anything like that. We're going to have to kind of work with the numerator and the denominator in order to figure out like what our boundary points are. So just like we did with the polynomials though, we want to make sure that our equation is set equal to 0. So if it's not already, you need to do that first. So first thing I'm going to do is move this 1 over here to the other side. So I'm just going to do that by subtraction. And so it's going to say 2x over x plus 1. And then we're going to move that 1 over by subtracting it. And that's going to be greater than or equal to 0. Okay, that's step 1. So sometimes it'll be done for you. Sometimes it won't. You'll have to maybe move something over like that. Step 2 then is to get a common denominator in order to simplify this. So in the past, when we worked with rational expressions and we had to like add or subtract them, in order to do that, we needed to have common denominators. So we need to think about how would I make these two fractions look like each other. Now the first one has that denominator of x plus 1. So my LCD, I'm just going to write this off to the side here, is just going to be that quantity x plus 1, which means you're going to take this 1, this minus 1 that we have, and you're going to turn it into a fraction. And to do that, you're going to think about this as being over 1, and you're going to take the top times our LCD, which is x plus 1, and you're going to take the bottom times our LCD, which is x plus 1. So we're not doing anything to that first fraction. It's going to stay the way it is right now. And then we have minus, and now this is going to say x plus 1 over x plus 1. Okay, still greater than or equal to 0. Now for my fractions here, I want to get them to just be one term. So I'm going to think about what happens if I subtract on my numerators, because now that I have like denominators, I can rewrite this where it's just all over x plus 1, and it's still greater than or equal to 0. But let's think about what happens if we combine the top. So if I take 2x minus an x, that gives me just an x left over. Now, when you think about the number, be really careful, because this minus sign is going to have to go to the x, which we already did. We subtracted that. But it also needs to go to that 1. So on the top, you're actually going to have minus 1 left over. Okay, so this is your simplified rational expression that combines that 1 that we had to move over. Now, in order to figure out what our like numbers would be, or our boundary points for the number line when we're trying to figure out what our solutions are, we have to look at this new expression. So we're using this to go on here to step number 3. Step number 3 is showing you what we're getting for our boundaries. And to do that, you have to set your numerator and your denominator equal to 0. So they're showing you down below, the numerator is this x minus 1. They're setting that equal to 0, and they're getting x equals 1. And then they set the denominator equal to 0. That's what's written here. And they get x equals negative 1. Now, also just keep in mind that this number here, this negative 1, this is that value that would cause the denominator to become 0. Okay, so because the number at negative 1 would cause an issue, because we can't have 0 in our denominator, you'll notice that down below, they put a parenthesis here at negative 1. Now, really right now, this parenthesis could have been facing this way or this way before you know where your solutions are. because of the way the brackets are facing, it's going to kind of give us a leg up in knowing like where our solutions would be. But they have parentheses there because the denominator can't have a -1. And so we're just kind of saying like that's going to be a number that doesn't work. So I can't include it in my solution set. All right. Now the 1 from the numerator, that isn't going to cause as many issues. So they do have a bracket on that one because the inequality sign has that equal sign with it. And so technically, if the denominator didn't have undefined values, I would have brackets on both of them. But because this one has a number that would cause an issue in the denominator, I have to just make sure I state that by using parentheses instead of brackets. Okay? And so they're kind of saying that down here. -1 is not in the solution set, so it isn't open, so it's a parenthesis. 1 is in the solution set, so that's why it's closed, and that's why we use the bracket. Okay, now we would start to figure out where are we going to shade, and so we test some points. So like we were doing with polynomials, we're going to test numbers that are on either side of my boundary point and in between. Again, I'm going to start with testing the number in between, which would be 0. If I put 0 in for my x, and I just, again, you can come back up to the very original equation to do that, or you could even come to this one that you simplified. Like when you get down here, you could use either one of these when you're doing your testing. I usually always just go back to the original equation. That's what I did with the polynomials on the previous page, so I'm just going to stay consistent with that. So if I put a 0 in, it would say 2 times 0 on the top, which would just be 0. And on the bottom, you'd have 0 plus 1, which is 1. And we're testing to see is that greater than or equal to 1. Well, 0 divided by 1 is 0. 0, is it greater than or equal to 1? No. So this is false. So I'm just going to put an F next to it. So I do not want to include 0, which again leads me to know like where I'm going to shade, but I'm going to continue to test other points just to make sure that I'm doing it correctly. So now I'm going to test like a 2 and a -2 because those are on either side of my boundary points. So if I put in a +2 for x, again coming back up here, 2 times 2 would be 4. And on the bottom, 2 plus 1 would be 3. 4 over 3, is that greater than 1? Well, that would be 1 1/3. So yes. So on this side, I want to shade. So it's kind of going over my number line. And then the last point I'm going to test, I'm going to bring it up here, is -2. So 2 times -2 would be -4. -2 plus 1 would be -1, greater than or equal to 1. That simplifies to a +4. +4 is bigger than 1, so that would be true as well. So that's how I know that I would be shading going away from each other, like shading all the way off to the left, all the way to the right. Now the last thing they want us to do is write it out in interval notation. So let's think about what we did with our polynomials. Since it goes forever to the left, what do I use to represent that? Good, -infinity, and then it goes up to what number? -1, okay, and you're going to have parentheses, and then our union here, and we start at what number on the other side? 1, is it going to be parentheses or bracket for the 1? Good, it's going to be bracket, and then it goes off to where? Right, +infinity, and then you always have parentheses around infinity because we can't put like an end on numbers. They just always are going to get bigger or smaller. So kind of similar to the polynomials as far as like putting on the number line, testing solutions. What changes is how you figure out what those boundary points are and kind of what to do with that, okay? Let's go to the next page here and let's do another one. Okay, so first thing we need to do is set it equal to 0. So let's move this 1 over. Okay, so it looks like that right now. What would be my least common denominator? Okay, good, the x minus 3. So we need to take, again, think about this -1 as a fraction is 1 over 1. So we need to take that times x minus 3 on the top and on the bottom. So we have 1 over x minus 3, and now minus x minus 3 over x minus 3, and then less than 0. Now let's combine this. Again, really watch that there's a minus sign here. Like this negative is going to go to the x and it's going to go to that negative 3. So when you're combining like terms, you want to think about that. There's no x's over here from the first fraction. So that negative is just going to apply. So it's going to be a negative x here. And then 1, you're going to do minus a negative 3. So that's a double negative. So you're actually adding and you get 4. And then this is all over x minus 3. And then less than 0. All right, so here's my equation. I'm going to go ahead and up here, I'm going to draw my number line. And I need to figure out what my boundary points are. So remember what we did after this is we set our numerator equal to 0. So you're going to set negative x plus 4 equal to 0. And you set x minus 3 equal to 0. And these are going to be my two numbers that I put on my number line. So if you solve this negative x plus 4, you're setting that equal to 0. What do you get for x? You end up with positive 4, right? Because you would subtract 4, but then you have to get rid of that negative in front of the x. What would we get over here? Okay, good, a 3. So now up here, I'm going to put 3 and 4 on my number line. And I don't really know which way I should face my parentheses or brackets here, but just what should be at these numbers? Like, should they have parentheses, brackets? Should I have one of each? What do you guys think? Okay, so you know that this 3 can't be included. So you know for sure you're going to have a parenthesis at 3 because that would cause the denominator to be 0. Okay, and what about 4? Why does 4 also have a parenthesis? Does your inequality sign have an equal sign with it? Not this time. So they're both going to have parentheses for this one. Now, if there had been an equal sign on my inequality, then the 4 would get a bracket. 3, no matter what, is going to have a parenthesis because it causes issues with our problem. Okay, so now what we need to do is test. So I'm going to let you guys try to do this. Test some points here. I would test 0. What's a number we could do between 3 and 4? I mean, you could do like 3.5 or something if you wanted to. What you could also do, because 3 and 4 are not included, you could test maybe just 4 if you wanted to and see if it works. But if you want to do one in between, like 3.5, I think that's probably safe to do. And then what's another one that we would need to test? Good. Yeah, like 5. Okay. So go ahead and take a couple minutes here. And I want you to go ahead and do those 3 tests and see if you can figure out how you would shade on your number line. Okay, so I kind of wrote out, you're plugging these numbers in here. This would be 1 over -3, so that would be a -1/3. -1/3 is less than 1. So this is true, which means that you would want to include 0, so you're going to want to shade this way. This next one would be 1 over 0.5, which would not be less than 1. Like if you take 1 divided by 0.5, that's not true. So this is going to be false. So you don't want to include the middle. And then this last one would be 1 over 2. So 1/2 is less than 1. That's true. So you would want to shade over here, which then means I know like my parentheses should go this way and they should go this way in order to include the shading. How would I write my answer in interval notation? Let's just write that above the number line. Okay, I'm going to write down what I heard you say. So you said -infinity to 3, parentheses on both, union, and then what did you say after that? Good. 4, comma, infinity, positive infinity, parentheses again on both of those. Very good. Okay, do we have any questions on how to do those with the rational expressions? Okay, we're going to move on to the last couple of problems here. And we're still dealing with polynomial or rational inequalities, but they're going to be giving them to you in a story problem. And so we're going to have to use the context of what they're describing in order to help us solve for our interval, like for our solutions. Okay, so we're still going to be doing similar things. Like we're still going to be thinking about what would these look like on a number line, testing points that would work, and writing in interval notation. So this first one says an object is propelled straight up from ground level with an initial velocity of 80 feet per second. Its height at time t is modeled by this formula: s of t equals -16t squared plus 80t, where the height s of t is measured in feet and the time t is measured in seconds. First thing they're asking is, in which time interval will the object be more than 64 feet above the ground? So they've got that formula, and instead of having 0 over here, they said greater than 64, because up here it says be more than 64 feet. So that's why they're saying greater than 64. So first thing we need to do is rewrite this so that it says 0. So I'm going to move that 64 over to the left by subtracting it. So it looks like that. Okay. And then something that I didn't maybe do on the last ones just because of the way that they were. But, I could maybe try to factor this the way it is. Something, though, that I'm recognizing is that I could probably take out a 16 from all of my numbers. That's going to make my polynomial a little bit simpler and maybe easier for me to work with. I'm also going to just take out the negative. That way I'm not having to deal with a negative a term. So if I take out a -16, I'm left with t squared minus 5t and then plus 4, and that's greater than 0 still. Okay, this is going to be a lot easier for me to work with when I'm trying to solve it. So we're going to try to factor this. What are the numbers that work for this? They both have to be negative, right? T minus 4, t minus 1. If you set those equal to 0, what do you get? Good, 4 and positive 1. Okay, so we would go to our number line here. And I'm going to put 1 and 4 on. Okay, these are like my solution points for right now. I'm not going to worry right now about like parentheses or brackets at the moment. What I need to know is to figure out like where's my range of numbers that works for this situation. So remember, I want it to be more than 64 feet above, so I got to figure out in which area are those going to be okay. So I'm going to test a couple points. I'm going to do something less than 1, which would be like 0. That's easy. I'm going to test something in the middle, like a 2. and something bigger than 4, like a 5. Okay, I'm going to test these numbers. If I put 0 in, again, I can come back up here to like maybe this equation, the very original one that I had. If I put 0 in there, I get 0 is greater than 64. Well, that's false. That's not true. So I don't want to include 0. If I put in a 2 for my t, so negative 16 times 2 squared plus 80 times 2, I have that comes out to be 96. 96 is greater than 64, so that's true. So that means in here, I'm going to want to include everything in between those two numbers. And then the last one, if I put in a 5, I got 0 is greater than 64. That's still false, so I do not want to include this. Now we're talking about in between these numbers. My inequality was more than. It didn't say like equal to 64, so I would have parentheses here. And so if I was going to write this in interval notation, I would write parenthesis 1, comma 4. So anything in between the range of 1 and 4 would be acceptable. All right, let's go on to the very last one here. Similar situation. They're giving us an equation that's talking about something that could be happening in the real world, and we want to figure out what's like my time that works here. So they're giving us a new equation. This V sub O is talking about like the initial velocity, and S sub O is talking about the initial position. T represents time. So this is saying you throw a ball straight up from a rooftop 160 feet high with an initial velocity of 48 feet per second, during which time will the ball's height exceed that of the rooftop. Okay, so there's some numbers in here that we're going to want to put into our formula because the V and the S, those are going to need to be replaced by numbers. We don't want to have a whole bunch of letters in this. That's not going to do us any good. So I'm going to bring down, I know I have this negative 16 t squared because I don't know what my time is. Okay, so that's what I'm trying to figure out because they're asking during which time will the ball's height be higher than the roof. So now I need to figure out which of these numbers, the 160 and the 48, like which one goes in for V and which one goes in for S. Okay, so remember it said that V represented your initial velocity and then S represents your initial position. So 160 is like where you started when you dropped it or when you threw the ball. And then it says an initial velocity of 48 feet per second. So the 48 is going to go in for that V. And then we've got a T after that. And then the 160 goes on the end here. Okay, we want to say which time will the ball's height exceed that of the rooftop. So I'm just for right now going to think about if it would just be equal to 0, what's going to happen here because we're talking about time. Okay, so now what I'm going to do is first see if I can take out anything to make this a little bit easier for me to factor. Can I take a 16 out of all three terms? Check that middle one. Does it work? It does? Okay, so let's take out a negative 16. I would be left with t squared. What'd you guys say, or what'd you find here? Okay, negative 3t. And then what would this last one become? Good, minus 10. And then we're setting that equal to 0. All right, so let's factor this initial, like this inner piece here. But how would that factor? Good, minus 5, positive 2. If I were to solve for t, what would you get for two potential answers? 5 and negative 2. Okay, now what did they say t represented? Time. Okay, and it's saying like feet per second, so I'm guessing that they're saying like they're counting seconds here. Okay, like how many seconds it would take for this to happen. Can you have a negative amount of seconds? No, time is never negative. Like even if you are doing something like faster than something else, it's never going to be negative. Like we would never say that something traveled negative 2 seconds or it took -2 seconds for something to happen. So I don't even think that this answer over here makes any sense at all. So I think we're going to want to only use the 5, which means that this is going to take 5 seconds after the ball was thrown. So in this case, I don't even really need to think too much about the number line here, because they just wanted to know at what point will the ball be higher than the roof. So they don't, I mean, there's probably other numbers that we could have in here, but they're just asking like, what's the boundary point where this would start to happen? And then you'd have other numbers that would be around that would also satisfy this equation. All right, any questions on those last couple with the story problems?